Okay, our next presenter is Leigh Whitcomb from Imagine Communications. And Lee's going to be talking about some tips for PTP system installation. And this one I'm really looking forward to. PTP is definitely a challenge, but if you use some good strategies and you pay attention and use some of the tips that we're going to be learning about here, it is the dragon that can be slayed, but you do need to engage with it. So Leigh will give us some pointers on how to do that. Take it away, Leigh.
Okay. Yeah, so the key thing in my presentation is I'm going to be giving you tips for successful commissioning, because there's lots of ways you can do it wrong, but I want to give you some tips on how to do it successfully. Just out of curiosity, how many people are actually deploying systems right now? Okay. How many people are thinking about it? Less. Okay. Also, if you have some questions while we're going along, feel free to sort of jump out. Okay, so a few myths here. So lots of people think that PTP systems are these sort of magical things that are very dragons and complicated things. Well, it is true that they're more complicated than analog black, but it's actually not that complicated. Okay, there's some other myths you may hear that PTP systems never work well, they always have issues. And it's true that some deployments that were done, this did happen. But really what the facts are is if you design it poorly, you implement it poorly, the devices have bugs, then sure enough, it will not work well. However, if you design it well, if you paid attention during Thomas's presentation on how to do the proper design, if you buy products that are implemented well and you go through the commissioning well, your system will work very well. So it's that there's definitely some false rumors that PTP never works well. It does work well if you just follow some simple rules, implement it right, design it right, buy the right equipment, commission it right. So now what I'm going to talk about. So Thomas taught you about how to design it. You've now wired it all up. Now you want to make sure, is it working correctly? Because the one thing about PTP is it can look like it's working right, but it's not. And these issues that can come up can be in how you've designed it, how you've configured all the devices, and then some devices have unfortunately bugs, which can also add some issues there. So a few examples of how things may not be working well. We're doing some testing with one customer, and their grandmaster, the message rate was supposed to be once per second, but it was actually sort of, sometimes it would be once every 2 seconds, sometimes it would send a message once every 3 seconds, and since the timeout is set for 3, if you don't send a message for 3 seconds, things were timing out, the BMCA was triggering, other devices were coming grandmasters. So these are sort of an example how the system mostly works, but doesn't always work. Or as Thomas was mentioning, how when in the lab it works, but when you get a real full-size system, it may not work. Other cases, or say on the switch, you can control what the delay request message is. Often the default is set to 5, which means once every 32 seconds. So yes, over time your devices will all lock up, but if you're trying to hit that performance where you want to say have it lock up in 5 seconds, if you send a delay request message once every 32 seconds, it's never going to lock up in 5 seconds. So it seems to work, but it's not meeting, say, your performance goals. So there's lots of sort of like subtle things like this that you sort of need to check and check carefully to make sure, is it working correctly? When you do failovers, will it fail over correctly? Another thing is, say, like on a boundary in a boundary clock port, the sync messages, announce messages will be just always set. So regardless if you set up all the unicast routing correctly, those messages will be set. So you'll get the time, but again, your delayed request messages may not be properly processed if you haven't set up all your unicast routing correctly or between switches and stuff. So without the delay request, your time will be close, but not as close as it could be if you want to get that sort of sub-microsecond accuracy. So again, there's lots of ways where it can seem to be working, so you plug it in, you see time, you go, hey, it's working. But when you look very closely, it's not. And that's sort of a definite difference from, say, when you're dealing with the traditional black. Just a couple slides here on some design stuff. So one very important thing is to get your vendors to sign off. So your grandmaster vendor, your switch vendor, and your media nodes. Because I've seen cases here where someone's come up with a really, really clever idea, which may theoretically be supported by 1588 and PTP, but maybe that switch doesn't implement that feature. And so they've gone to the effort, they've ordered the equipment, they've wired it up, and the switch vendor says, look on page 7 of the manual, that's not supported. So yes, some of these manuals are quite large, and technically you could have read that yourself, but a lot of times it was just easier. While you're at the paper stage, and it's much easier to change your design, is catch the design at the paper stage before you implement it. And so definitely get your grandmaster, the vendors for your grandmaster devices, for your switches, and your key media devices, so your processing devices. Make sure they all take a look at your design and they all agree, yes, for my device and how you want to use it, this will work. So I strongly recommend you contact those 3 people, and they should be reasonably happy to sort of spend a few minutes with you and sign off on your device, because if not, you'll be calling us later, and that'll just cause everyone more pain and grief. So, just showing sort of a typical design. As Thomas was saying, every design is a bit different, but this is kind of just a generic design that I'll sort of be referencing later in the presentation. So you see, typically you're using a 2020-7 redundancy, so you're going to have your sort of A side and B side. So you'll have sort of 2 sets of switches. Typically you'll have everything set for boundary clock mode, because this provides sort of that decoupling and some security stuff. You may have then a grandmaster connected to both sides. As Thomas touched on, you don't want to use that sledgehammer, that P1, so you want to keep the P1 values the same on both sides. Use the P2 value to differentiate. There we go. You want to set up which ports are master and which ones can be master slave. So for protection here, to prevent, say, rogue masters by forcing these to master only ports, you'll prevent that. And even on your end devices, they all should be set to slave only, because there's no reason they should become a master. That will just cause you grief. So not the only way to design things, but this is sort of a good kind of reference design to consider. Okay. In terms of parameters, using the AS67R16 defaults is sort of a good thing. I mean, you may have some really, really good reason why you want to deviate from these, although I've actually never seen an application that anyone had a good reason to deviate them. So strongly recommend just keep with those values. Also, in the new version of 2059-2, which is going through its 1-year review after 3 years, it's going to change to these values. So you want your announce interval set to 0, or 1 message per second, your announce timeout at 3, and your sync interval at -3 or 8 messages per second. So these have been well tested in the industry. They've been well tested at all the interops. They're a nice compromise between lock time and messages too fast. So these values work really, really well, and unless you have a really, really, really good reason, I would not deviate from these. So one thing as you're going through the commissioning is you need to understand the expected behavior of your network and your devices. So it will sort of vary a bit depending on the specifics of your network, but you do need to understand exactly how it's going to work. And we'll sort of cover that. And also during the commissioning, you're going to want to verify the grandmasters, that they're configured and performing correctly. You're going to want to verify the switches are configured and behaving correctly, and all your media nodes. So you need to sort of check all these 3 different devices. You're going to have a sort of a checklist, because there's a lot of things you want to check. So you're going to have a checklist to go through each of these devices. And then you're going to run various tests and experiments and collect various data to make sure things are set up right and behaving as you expect. So the first thing is basically understand what is it you expect the system to do. Then you're going to test your system, making sure it is behaving that way. So for this commissioning checklist, you're going to have all the different things you want to check in this list. I'm going to slide a few examples, but it's quite a long list. And then for each item, you want to have a clear pass criteria. What is the value that is what you want? What are the ranges that are acceptable? So you want to sort of document all this, and then you'll run this checklist on your facility. So when you're looking at, say, the Grandmaster, so in the Grandmaster, you're going to be checking things like the sync interval, announce interval, the priorities, the communication modes, the delay request. You're also going to want to check what the actual values are. So in that one example I gave you before, there was one Grandmaster vendor who, even though you set it at 1 message per second, and if you looked at the message, it claimed that it would be sending them at 1 message per second, when in fact sometimes it was sending them every 2 seconds and every 3 seconds. So as part of the test, you'll want to go through and actually measure, are the message rates, is the sync interval as you expect? And then sort of the first part, you also then want to make sure you've configured it right, because if you tell it the wrong value, you're obviously starting on a bad foot. So you want to make sure you've configured the devices correctly, and then verify that they are behaving as you configured them. So here's a sort of example of the checklist I have. It goes on for a lot more pages than this, but this is just sort of...
Let me try to fix your microphone.
Okay.
Go ahead. Bring it up.
How's that? Good, good.
Okay.
So this is just a...
All right, what is going on?
I don't know.
Any idea? Here, let's swap it. Give me some level.
Some level. That sounds a bit better. Okay, much better. So this is an example of that checklist. This is not a complete checklist, but just to give you an idea. So, I mean, you have different, sort of broken into different areas. I've indicated what are the sort of past criteria. Then you'll sort of, as you're going through, you'll basically check off, yep, it's that, yep, it's that, no, it's not. So this list goes for quite a while. So if you basically go through this checklist, once you've sort of checked everything off and it's passing, then you should have a good PTP experience. So this is sort of the checklist and focusing on the Grandmaster. So then when you go into the switches, again, we'll have checklists, but we'll want to check different things. So typically the switches will be configured in boundary clock mode. When you're setting up the switches, there'll be some of the parameters which are global parameters, which affect the switch as a whole, so like boundary clock enabled. There'll be other parameters which are on a per port basis. So for every single port on the switch, you'll need to configure them. Kind of a typical trick I'll do is that in most of the configurations you can say interfaces 1 through all of them, set parameter, set parameter, set parameter, and that will help ensure that you get the right parameter on each interface. Because if you go through interface by a time, you might make a mistake. If you got like a 72 port switch, you might make a mistake on 1 port. So by doing them all at once, you're more likely to get it right. Then when you're going through some of the testing, you're going to sort of have some tests that you want to look at. One of the ports will be acting in a slave mode, so there'll be various sort of states and stuff you'll want to look at on those. Most of the switches will have counters, and you'll want some of the checklist items are you'll want to make sure that those counters are counting correctly. Are you receiving delay request messages? Are you receiving sync messages? Are you sending sync messages? So there's various counters that you'll want to look at. And then each of the ports which are in a master mode, which is most of your ports, they have different counters, or different counters they'll be counting that you'll want to be checking. So you'll need to check the ones which are slave one way, the ones which are in master port differently. So again, another checklist where we're going to go through the global parameters on the per interface. Like I say, this list, I have a much longer list, but again, this example of you want to sort of check what makes sense for your setup, what are ranges that make sense, and then sort of check off pass, pass, fail, fail. So then we have our media nodes, which is sort of the bulk of our network. So these are all our cameras and multi-viewers and gateways and so on. So in the TRO 1001, it's called media node. So there we want to verify all the different PTP parameters are set correctly. We want to look at, is the device locking? And we'll also be wanting to do packet captures to make sure that the traffic between the devices is what we expect. We actually may also want to do those captures between the Grandmaster and the switch too, because some of the tests we want to do, we want to look at very detailed like message rates and stuff. So we'll want to do captures that way. So again, another checklist here. So some new things in this. Well, you may also have this on the slave or on the switch one, but things like, so here, what grandmaster ID? So what grandmaster am I locked to? Because within your network, you probably had 2 grandmasters. You want to record, here's the grandmaster ID of each of them, so you want to make sure that your device is locking to the grandmaster that you expect. You want to know, I mean, is the device locked? Does the time sort of match your UTC time is a good thing. So there's a whole set of parameters you want to go through, figure out what is the acceptable range. So things here like the one-way delay. So this is using the delay requests. Well, typically if you're connected to a boundary clock, I mean, that should be well below 1 microsecond. So if you see that that number is something really big, then that might tell you you've got something wrong in your network. So for each of these parameters, you want to know ahead of time what is the normal and expected ranges, and then check it off. So what are some of the tools we're going to use? So you have these checklists to do these experiments. How are you going to collect the data? So in the devices, they'll have different sort of GUIs and APIs that you can get the data from. So there'll be sort of lock presence. There'll be various counters and stuff. One thing which is sort of unfortunate is every manufacturer does it a bit differently. So one might call it PTP locked, and one might call it PTP unlocked, and one will give it. And so not all the parameters are available on every device. So this is sort of a challenge right now in the industry. You want to do WireShark captures, so using some sort of PCAP device, so you can verify the fields. And there's various tools like PTP Hound and some others that you can then look at the protocols. So WireShark is free and an extremely powerful tool. So here you can sort of do your captures. You can sort of make sure that things make sense. So we got our sync messages, our follow-up messages, our management message, which is our SMPTE TLV. We can click on the packet. We can make sure that the domain we're seeing matches our PTP domain. We can double check here. So the log sync announced period here, this is the sync rate of -3. So I can see that, yes, at least the grandmaster here thinks it's sending at the right rate. Again, I want to sort of measure to make sure that it actually is doing that, but I can sort of check all these fields in the packet. So some of the checklists will basically say, pull up the packet in WireShark, check to make sure all the fields are set right. So this is sort of a good place, like say on that delay request, where sometimes they get set to 5, which is 32 seconds. You'd sort of see it here. It's like, oh, of course, that's set wrong. So when you're doing the WireShark captures, a few notes there. So if you want to check it on the device, you want to do a port mirror. Now, one sort of caveat or thing to watch out with port mirroring, depending on which switch you buy, which model, which chipset they used, it's often that PTP packets are not port mirrored at all, or only certain directions. It may only be the inbound, it won't be the outbound. So that's sort of a very cautious thing, that it's like you may not be able to collect the data you want. One technique I use is sort of, if you want to check the switch in general, if you just use some random unused clock port, you can then record the traffic from that. Yes, you're not going to see delay requests, but at least you can see the sync and the announce and the management message. So you can check a lot of those. So that's one technique. If not, you sort of have to just be careful depending on exactly the switch that you have. And many of them do not do the port mirroring of the PTP packets. They'll do all the essence packets, so you can do all your 21 and 10 analysis, but unfortunately not the PTP. So you may rely more on the counters that are in the end devices. So if you want to look at, say, the actual message rates, so you want to see how often the messages are going. So a very simple technique you can do in WireShark is you just can do a filter. So you can click on your announce interval, click on filter, and then you can set the time mode to delta from previous packet, and then you can just sort by time. So here's a capture that a customer who's having this issue with, they sent me the packet capture. So up here, I've said, well, by clicking on the packet, it'll then create a filter for you. So this basically is a filter for announced messages. I click on the view time, and I've set it to delta between previous packets, and then I just clicked on sort. And so here you can see that some packets were 1 second apart, so those are or close to 1 second, because the standard allows you to add a little bit of intentional wander or jitter, which is good. But then here you'll see a bunch of packets are 2 seconds, and that's not as good. And here there's even a packet at 3 seconds, which was really bad. So this is a very simple technique that, I mean, WireShark is free. Doing a PCAP is quite easy. So using this technique, you don't need any fancy test equipment. It's basically all free stuff. When you are doing sort of some of your initial commissioning, it's not uncommon that, say, like in that last capture, it took about 24 hours to get one of those bad packets. So when you're doing sort of your initial commissioning, it's definitely important to capture for, say, 24, 48 hours, because you may see events, and I've seen this various different events, that may only occur once a day, once an hour. So you do want to do quite a long captures and analysis. Now, the good thing with PTP, given that it's 8 messages a second, if you do a PCAP, I mean, it may only like 100 meg PCAP will get you 24 hours or 48 hours of capturing. So unlike our Essence traffic site, it's very hard. By setting up the right, just filter only on PTP packets, you can easily do very, very long captures and have all the packets to then analyze. And they said, and doing that whole length is important because especially when devices have a few bugs, it's not uncommon that it's once a day, once every 2 days. It can be quite infrequent. And it sort of drives you nuts because you say, why do my operators see this video glitch once? And then it's like, it happened once a day. Well, it's because your PTP glitched, then it'll cause your sort of essences generally to glitch. Another area that you want to make sure to test is sort of the redundancy in your failover, and sort of does it behave as you expect? So one important thing with this is it's critical to understand the exact behavior of what your system should do. And this includes how the ports are going to change state, what is the message like events. And the one thing is that when you fail over, say, from Grandmaster A to Grandmaster B, there should be no noticeable impact. I mean, yes, the Grandmaster ID may change, but this should cause no glitches. So if your PTP system is done correctly, then there should be no glitches. So that's another thing is that you're going through these checklists and you do these failover experiments. So you want to make sure the right device takes over, but you also want to make sure that none of your media nodes glitches, because unfortunately, if the ID changes, then it'll glitch. So just going through a couple examples here. So here, so still testing question for the audience. So the GPS antenna fails. How many Grandmaster ID changes should I see in this event?
This will work.
This will work? Okay. So in this case here, so if a GPS antenna fails, what is the progression on PTP? What will happen? What's that? No, just one. So what's going to happen here, so the GPS antenna fails, the clock class of this device is going to go down. It's going to go from I was GPS locked to I'm out now was GPS locked. He's going to happily pass it on to this device, which will pass it on to this switch, which will pass it up to this master. This master will then say, oh, my clock, I'm locked to GPS, which is better than you, which is locked to not GPS. And because of that, then I'm going to become master. So then it's going to start pushing its grandmaster and start sending announce messages, which is going to go back to this boundary clock, which is then going to go to your media node. So under this situation, you're going to see the clock, the GMID basically change from this device. Then you're going to see only the clock class field drop. Then you're going to see it jump over to this one. So when you're analyzing it, that's what you sort of, when you're measuring down here, what you should expect. Now, very simple or very subtle change here. So instead of the antenna failing, imagine the Grandmaster itself totally failed. So how many Grandmaster ID changes am I expecting in this failure? So it's 2. So in this case, when this device fails, this boundary clock is going to say, oh, I'm stopped seeing announce messages. So it's the announce timeout will expire. He'll basically take over as Grandmaster. Then he'll basically send it over to here. This guy will say, oh, I'm a better Grandmaster than you. Then he'll push it back. And so if you're looking at the media node here, you'll see 2 Grandmaster ID changes. One will be quite a transitional one. Now, operationally, again, this device should not have a glitch and it shouldn't impact it, but you will see multiple Grandmaster ID changes. So as you're going through your testing, you need to sort of think, okay, if I fail this link, if I fail this link, if I fail this device, what is the series of events that's going to occur? And then when you run the experiment, do your PCAPs, you want to make sure it matches. Because you may find that, oh, maybe these two links aren't configured right, so when you fail this device doesn't take over properly. So you want to make sure for all your sort of failure scenarios, you want to do this ahead of time during the commissioning and not while you're doing some sort of live production and stuff. So it is important to sort of go through these different scenarios, test them during the commissioning, and it does require a bit of thinking, but you need to go through every combination and think through what are all the messages, how they're going to change, what's the behavior. So as Thomas was mentioning, monitoring is very important. So we want to monitor very critical parameters, things like GMID, lock status. You want to sort of detect when parameters change in the system. So some good news here, where I mentioned before, every manufacturer does it a little differently. SMPTE does have a very active working group that's basically trying to come up with parameters for PTP monitoring. So we're coming up with, here's the name of the parameter, here's the enumeration, so that devices will all implement, hopefully, maybe next year or something. All the devices will, they may not do all the parameters, but at least all the critical monitoring ones will all be named the same, have the same states, behave the same across all devices. So we're creating this standard, then manufacturers will hopefully implement it, and then this will make monitoring much easier for all you guys. So in conclusion here, so PTP may seem like it's working, but really it's not working correctly. You may have failure cases that won't behave correctly. The performance might be not as you expected. So just because it seems to work doesn't mean that it's really working. You need to understand at a very deep level what is the expected behavior of your system. You need to have these checklists to go through so you can, because there's lots of things, you'll sort of forget details, so you need these checklists to make sure that are all the devices, the grandmasters, the switches, the media nodes configured and behaving as you expect. You need to thoroughly test all these devices at all the different levels. You need to run your failure or your redundancy failover tests ahead of time to make sure the system behaves as you expect. And if you design your system well, you implement it well, you get products that are implemented well, you commission it properly, you will have a very good PTP experience and it will work very, very well. Thank you, everyone. Any questions?
Thanks, Leigh. So you're kind of repeating a theme we heard earlier today about test and then tested. You tested your test.
Yes. And also remember what your results, what's a pass?
Right.
What's a fail?
What's a pass? Do you have any other than checklists and things like that? Are there any? And we saw the WireShark. Are there any other testing tools that you've used that you would recommend? You know, stuff that's available for people to use.
Yeah, there are various monitoring systems. There are test tools that are available. They're not always the cheapest. So, I mean, I find for a lot of stuff, WireShark is free and very effective. Doing some of these things, as I said, it can be done very cost effectively at zero. And then adding your monitoring system so that after the commissioning phase, you want to sort of be measuring throughout the entire life of the system, because you may have someone plugs in a rogue device, a device just goes berserk for some reason, someone's trying to do a GPS jam on your system. So you want to have that monitoring system. So there's a variety of monitoring systems that you can sort of purchase that will talk to the switches, talk to all the end devices, so that you're always doing that monitoring.
Okay, great. Any other questions? Yeah, hold on.
Thank you. Are the timestamps in WireShark accurate enough to make decisions on how good these packets are?
It's a good question. So a couple different things. So certain failures are sort of protocol related. So from those, you don't really need any kind of timestamp. So if you want to just look for a protocol type violation, you can just use plug a PC and do the WireShark. There are other times when you want to look at more fine detail, like say that 3-second issue. And even at that level of coarseness, even just a regular laptop is good enough. There are other things which you want to get, even like if you want to make sure, are you achieving that 1 microsecond, 2 microsecond accuracy, then you do have to have a proper capture device. So WireShark capture files do have the accuracy, you just have to make sure you get the right device. So there are basically devices you can buy which are specific hardware-based PCAP capturing devices, and they get accuracies down to like less than 20 nanoseconds. So those devices are available for sure. Or you can sort of buy certain NIC cards on sort of running on a Linux and then run the right software. So there's a variety of ways of purchasing a device or just making sure you get the right NIC card with the right software. There was the EBU have actually come up with a sort of a system with Mellanox that you can just use a relatively regular NIC card. They have a presentation, actually was part of the JTM tested, because not all devices can buy very high-end capture cards or high-end capture machines. And so for only a few $1,000s, you can sort of put together a pretty high-end capture. But for a lot of the tests that you're doing, you don't even need that. For protocol not required and gross failures, which account for most things, you can get away with just a PC.
Okay, that's all the time we have, Leigh. Thank you very much. And our next speaker is right on deck, and we're ready to go. So thanks.